Okay, so today we're going to talk about an arithmetic sequence and a partial sum. So today should be easier than the first day because this is a specific type of sequence. Okay, so the pattern is easier to see. Okay, the rules are easier to follow. So an arithmetic sequence is a sequence whose consecutive terms have a common difference. So if you look at this first sequence listed here, 7, 12, 17, 22, and 27, if you were to subtract the consecutive terms, so 12 minus 7, 17 minus 12, and so on, you get the same difference each time. You get a difference of 5. So that is the common difference. But now if you look at this sequence where you have 1, 4, 9, 16, we can recognize hopefully that this is n squared. And when you go to subtract these consecutive terms, you don't get a common difference. You don't get the same value of d each time. So this is not arithmetic. Okay, does that make sense? Okay, so the nth term of an arithmetic sequence, this is an important formula to know. So you definitely need to memorize this. There's quite a bit of memorizing in this unit, so you know, maybe you want to make some note cards or something. It's your choice. A sub 1 is the first term. N is the number of the term that you're on or trying to find. And D is your common difference. Okay? The recursion formula is common sense, really, here. It's saying that in order to get the next term, you take the previous term and you add the common difference. That makes sense, since all of them have a common difference and you're adding the same number each time. Okay, so you can memorize that if you want, but again, it's kind of common sense. Alright, so let's take a look at example 1. Write the first 5 terms in the sequence and then determine if the sequence is arithmetic. So the first thing we want to do is just like we did in the very first example in the last set of notes, right? You plug in n equals 1, 2, 3, 4, 5. You find the numbers. The only thing here that we're doing different is that we have to see if there's a common difference. So let's find the first term. So a sub 1 is going to be 2 to the 1 plus 1. So 3. And then the second term is 2 squared plus 2, so 6. The next term, 2 cubed plus 3, 11, and then so on. You get, what, 20 and 37? Okay, so that was the first part. They just wanted the first 5 terms. That's easy. Right, it's just plugging in our n value and then simplifying. Now you want to determine if it's arithmetic. In order to determine that, all you have to do is find out if there's a common difference. So we're going to take our consecutive terms and we're going to subtract them. So 6 minus 3 is 3. 11 minus 6 is 5. We can stop. Right? Because in order for it to be arithmetic, every single time you subtract those consecutive terms, D has to be the same. So it's not, so this is not arithmetic. Yes?
Will you mark us down if, like, we can notice without, like, writing down if they don't have the same difference?
Yeah, no, you don't have to show, there's not a ton of work to show for these, no. Okay, now look at B. We're going to do the same thing. So we're going to find the first 5 terms. So 1 plus 1 minus 1 times 4. We're going to get 1. Our second term is going to be 1 plus 2 minus 1 times 4. So 5. And you can find the others. Okay, so do you notice a common difference here? Yeah, the difference between the consecutive terms is 4, right? As we go down the line, they're all the same. So that means that D equals 4, and this is arithmetic. Now, let's take a look at A sub n here. If you were to simplify this, if I was to distribute the 4 combined like terms, I would get, let's see, 4n and then minus 4 plus the 1. So minus 3, 4n minus 3. What do you notice about this? It's linear, which means that it has a slope, right? The slope is the common difference. That's what it's going up by each time. So even from the beginning, you should recognize that this is arithmetic because you can see that it's a linear equation. Where if you go back to A, it was not, right? It was exponential. So we can see the difference between the two. Questions? All right, moving on. Okay, find a formula for A sub n for the arithmetic sequence where A sub 1 is 15 and D is 4. So they're already telling you, like, hey, heads up, this is arithmetic, the common difference is 4, and you have the first term. Go back to that formula we're supposed to memorize. It's A sub n equals A sub 1 plus n minus 1 times D. All they want is the formula for A sub n. This is how you find it. In order to find it, you have to have the first term and the common difference, which we've been given. So this is why you need to memorize that formula, okay? So now we're going to plug it in. A sub n equals the first term, which was 15, plus the quantity n minus 1 times the common difference of 4. I do want you to simplify it so that we can see it in its linear form a little bit more clearly. So A sub n equals what? 4n plus 11. Questions on that one? Yeah?
So if we can recognize that the equation they give us for like example 1b, if it's set up the same way as that formula, can we just automatically say it's a arithmetic?
Yeah. Yeah, you can. The only thing is that in like example 1, it did also ask for the first 5 terms. So you would still have to, you know, calculate those first 5 terms, but yes, definitely. I want you to be able to recognize that, okay? All right, example 3. Find the missing term in the arithmetic sequence given A sub 1 is 3 and A sub 2 is 13. They want us to find A sub 9. Okay, so again, they're telling you this is arithmetic. What does that mean? We have a common difference. And how do I find it in this case? Yeah, it's just 13 minus 3. They've given us 2 consecutive terms. So I know that D equals 10. Okay, so this formula, A sub n equals A sub 1 plus n minus 1 times D, will allow me to find any term within the sequence, right? I'm looking for the 9th term. So that means A sub n is now A sub 9. And then I just plug in my information. I have the first term, it's 3, plus, I'm looking for the 9th term, so n minus 1. I mean 9 minus 1. And then times that common difference of 10. So the 9th term here is 83. Did you have to do it this way? Zan?
The regular way is that's like kind of like coordinates would be 1, 3, and then 2, 13, and
I see what you're saying here because it's linear. But we already know the slope. You're saying like plug it into an equation. Like, okay, yeah, which is essentially what this is, right? It's really just the slope formula kind of deconstructed. Daniel?
I found the value from D, then I subtracted 9 and 2 to get 7, so I multiplied D by 7, and then added the second one.
Okay, so you kind of did the same thing, except you really kind of manipulated the formula by using the second term rather than using the first term. That's fine. I'm thinking of an easy way, like what if I don't remember the formula? And what should I do?
minus 10 and 3.
Or how about add 10, right? If I add 10 until I get to the 9th term, I'd be done, right? The 9th term isn't very far away. You can just keep adding 10 each time. But what if it said, like, find the 100th term? That's a horrible method, right? That is a horrible method. Some of you would probably still use it, but it would take you a lot of time. Where this, knowing the formula, you know, would be much easier. All right? You see what I'm saying there? So sometimes, you know, just use your common sense. How can you get there if you don't always have to do it so formally. Okay. Example 4. Write the first 5 terms in the arithmetic sequence given a sub 4 is 16 and a sub 10 is 46. So I'm looking for a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. I do know that a sub 4 is 16. How am I going to find those other terms? Ethan?
Can you subtract 46 by 16 and divide by 6?
Why 6?
Because 4, 10 minus 4 equals 6.
Right, so in between these two terms, there are 6 terms. Right? There's 6 terms between those, and we know that this is arithmetic. They already told us there's a common difference. So we're just figuring out the common difference, and this is how you do it. And again, this is kind of informal, right? This is just kind of common sense. You subtract the highest minus the lowest, and then do the division of how many terms there are. So this is going to give us 5. D equals 5. Now, I could write the rule, right? I could write out an a sub n rule, and I could plug in 1, 2, 3, 4, and 5. But what would be quicker and easier? Yeah, subtract 5 to get these terms, add 5 to get this term, right? I know that there's a common difference, so that's what I'm going to do. Isn't today easier than the other day? Because this is a specific rule, right? This is easy to follow. There's like one formula to use. It's pretty nice. Yes, this is pretty easy. Okay? All right. Let's continue. Yeah, they could be. Now, the sum of a finite arithmetic sequence. This is the next formula. You do have to memorize this, but I'm going to change it a little bit because I think it's easier to remember this way. So S sub n equals C divided by 2 times A sub b plus A sub n. I know what you're thinking. This looks exactly the same, but with more letters. Okay? The problem with this is kind of confusing, in my opinion, because of this a sub 1. It confuses me because it doesn't mean that it has to be a sub 1. It means that it has to be the first term in the sequence. That could be really a sub 5, okay? So this a sub b that I replaced it with is representing the first term. Bless you. A sub n is the last term. And I guess really this should also say C, now that I'm thinking about it. And then C here is how many number of terms there are. Okay, so this is finding the sum of a set number of terms. Okay, remember finite means there's a set number of terms within the sequence that we're trying to find the sum of. Okay, so this is similar to what we did the other day. Now, when you take a look at example 1 or 5a, should I take the time to plug it into a formula? No, I have the list of numbers they want me to add together. Just add them together. Okay? So there's 1, 2, 3, 4, 5, 6, 7 terms. So the sum of these 7 terms is how you would write your answer, and then you add them together. I think you get 70. Okay, don't waste your time with a formula when you could see what you have to add together. Okay? Now B is a little different. So B, I can see the first term. They want me to add all the way to the 25th term, but I can't see all 25 terms, right? So this is where I'm going to have to use my formula. So the sum of the first 25 terms is going to equal the number of terms, which is 25, divided by 2, times the first term. Can I see the first term? Yes, it's 2, plus the last term. Can I see the last term? No, so I have to find it. So this is like a sub 25. So So before I'm able to use my formula, I have to find the 25th term. So I'm just going to do that on the side here. So a sub 25 is going to equal. Now how am I going to find that? The other equation, because that tells you a sub n, right? A sub n equals a sub 1 plus n minus 1 times d. So I need the first term, and I need the common difference. Here's the first term. Can I find the common difference? Yes. It's just 6, right? So d equals 6. So I'm going to have 2 plus 25 minus 1 times 6. You can find any term using that formula. Or you can just find the general rule using that formula. Okay? So 24 times 6 and then plus 2. My 25th term is 146. So now once I've done that, I can plug it in. So I'm back to my sum. So I'm going to have 25 over 2 times 2 plus 146. And the sum of the first 25 terms is 1,850. We should also probably highlight this so you remember you have to memorize it. Okay, everybody okay on B? Finding that 25th term and then using the formula? Okay, C is different. Why? It's not a list. This time I have the general rule, okay? So I can just find what I need using the rule. So let's think about what we need. First of all, how many terms am I trying to find the sum of? 100. So S sub 100 equals 100 divided by 2 times my first term, which in this case is going to be a sub 1, plus my last term, which should be a sub 100. Neither of which I have yet. I just need to find them. So I'm going to find a sub 1 by plugging in 1 for n. So 8 minus 3 times 1 divided by 16. You get 5 over 16. Okay, now I also have to find my 100th term. So a sub 100, and I'm going to plug in 100 for n. Okay, when you divide and simplify, you're going to get negative 73 over 4. So now I have that first and last term, and I can go back to my formula, and I'm going to plug it in. So 5 over 16 plus a negative 73 over 4. Multiply that by 50, and the sum of the first 100 terms is negative 7,175 divided by 8. Yes?
So you couldn't just put that into your graphing calculator?
You could.
Do we have graphing calculator?
You do. But if I ask you to show work, you're going to have to know the formula. Okay? Alright, look at D. Isn't this like the same thing? Except what? Doesn't start at 1. Right? So this is why I wanted to use the formula of a sub b, because when I see a sub 1, sometimes I think, okay, I got to plug in a sub 1. But you don't. You plug in the first term that they're asking you to find. So how many terms are there? There are not 20. There are not 25. There are 21. Now, let's do this. Make it easier. Think about from 5 to 10. 5, 6, 7, 8, 9, 10. There's 6 terms, right? This is like saying like you're going from 0 to a number. You have to add on an extra 1. So here we subtracted, right? And we got Or I mean, we just saw from 1 to 100 is 100 terms. So if you subtract, you get 99, but you got to add an extra. Just like here, 25 minus 5 is 20, but then you got to add on an extra term. Okay, there's really 21 terms here. So be careful with that, because that seems like such an easy step, but it's not. Okay, so 21 divided by 2. And then we have to multiply it by the first term. So again, we have to find those terms. So a sub, and now in this case, am I going to plug in a sub 1? No, I have to plug in a sub 5, because that's the first term in the sequence they want me to use. So I have 4 plus 5 minus 1 times 3, 16, and then I want to plug in my 25th term, 4 plus 25 minus 1 times 3, and that's 76. Okay, so be careful with that. And then we're just going to plug them in, so 16 plus 76, and we're going to multiply that by 10.5, and the sum of the first 21 terms, or the 21 terms in the sequence, not really the first 21, is 966.